the different types of topologies available to us in LANs. You've seen a screenshot, I think, in week 2, where we did the screenshot handout of the different topologies: the star, the hybrid, the bus, the ring. Tonight we're going to explain a little bit more detail about what those are and the advantages of all of them. Lay out your computers within your network is basically all it is, the word topology. And the word topology is used in a lot of different disciplines, and in networking it deals with the layout of computers within your network. It's a very broad scope. It does not specify device types in a topology. It does not discuss connectivity. We do not discuss addressing schemes of IP. It's basically just a methodology before you build something, before you build a network, basically. And the fundamental shapes of topologies are bus, ring, star, and hybrid. The most popular today would be the ring. It's the newest. But as businesses grow, it's not uncommon when you get your first networking job to walk into a hybrid area, meaning all of them together, basically. You might have an old room that has 2 or 3 old PCs connected to a bus topology. You might have another room connected to ring topology. You might have a new room that's built on with the star topology. And so topologies are, again, just brainstorming to figure out what's the best solution for your area. Just because star is the newest doesn't mean you wipe everything out in your network and say, we're going to install star everywhere now and wipe everything else out. Really, it's kind of not really cost effective to do that. And so we're going to talk about types. So the bus is the first one we're going to look at. It's basically a single cable, and if you remember from the handout I gave you, it's a coaxial cable, just like the one for cable TV at home, for internet or television. It has connectivity to all the networks and all the nodes within the network, meaning all your NIC cards. There's no intervening connectivity devices like a hub in a bus. Originally when you build it, you have one shared communication channel, and the coaxial cable is the medium, unlike the Cat5 like we're using tonight. It's a passive topology. It just listens all the time, accepts data, and it's broadcast. It's quite fast and efficient when it comes to data flow, but it's more expensive because the cabling is more expensive to create and to buy, both, either one, create or buy. So the domain is called a broadcast domain. It's where basically the nodes communicate using broadcast transmission, and there's terminators on both ends of a bus. I'll see if I can draw a nice ugly picture here. So here we have on both ends a nice terminator, okay? And then we'll pretend in between here is all of the connections to NIC cards. All right, so basically that's roughly how it looks like, an elongated pattern, basically a long room. So each one of your rows, if we said had a bus, would have a terminator on both ends, and then, or at least one end, and then the other end might converse to another row or to a switch or hub. It has, and what basically terminators are for, it stops a signal at one end of the wire, so because it has nowhere else to go. It has something called bounce, signal bounce, where basically the signals travel endlessly between 2 network ends, and one grounded end that removes static electricity from the mix. There we go, I think that's where we were. Then on the right, we've got the terminator on the left, and you'll notice the flow of data is constant and moving all the time. And very efficient, and that's all we had for years when networks first came out, because we didn't have Cat5, so this is what we used. And the NIC cards actually had connectors on it for the Cat5, or not the Cat5, the coaxial, twisty kind of, it looks like these right here, these little twisty type of connectors. It's different than the one for your TV. You know how your TV has like the male-female screw into the television or into the modem. This is more like it has two, basically like this. I'll show you. It's got like a bar here and a bar here on the terminator, and the terminator comes in over the top of it and twists onto these two bars to lock it in to place. The advantages of bus are that it's relatively inexpensive as far as if you already have the cable. If you're having to buy it, it's more expensive than Cat5, but it's not. It's cheaper than fiber. It's cheaper than fiber. Disadvantage: it does not scale well, just because of the scope of the hardware and the cabling, and it's difficult to troubleshoot because you have to go row by row or build it or room by room to troubleshoot, unlike a star where you're basically just using a hub to troubleshoot those connections to that hub or to that switch. And it does not have fault tolerance, meaning there's a lot of drop data in this type of network, but data does get there. Next is Ring. This is the one where, remember, you have two nodes that talk one to another to the left and right. So on this one, the way it works is if this was a computer sending data to, say, this computer here, these two nodes, as it goes across, would duplicate the data, and then once it gets to this, it would X out that, and then finally end up with the data on the end that it needs to go to, or the end that it needs to go to once it's sent. It's a circular network, clockwise, like I drew up here, as far as one directional. It's not omnidirectional, it's unidirectional, and so just one direction only. It's very active, meaning that the workstations itself, as you can see up here, work in the data transfer, unlike bus and star that we're going to talk about. So workstations themselves have what's called data stops to do some investigation and duplication and then carry it on. So it looks at the data, duplicates it, carries it on. Looks at the data, duplicates it, carries it on. And it keeps that data until the data is delivered to its source or to its destination. Once the data is delivered to its destination, all the data on those machines are then destroyed, if that makes sense. So there's a lot of redundancy, but it's good if you want data to get there, and it has to get there, like New York Stock Exchange still has ring topology, military, banking. And in this one, you can use either twisted pair like Cat5, fiber optic, even the bus, even the coaxial can be used in this as well. Drawback is malfunction workstations can disable a network. So if this baby malfunctioned, it would cause a problem on that data flow. Now, eventually, the network would realize it caused a problem, or it failed, and it would hop over to this one eventually. But it can cause problems. Not that it would stop the data, but it would cause issues and take longer to get there. Not very flexible or scalable like the bus. It's an older topology, but it does work. And I think I mentioned, if I didn't, I believe I did, you guys correct me if I'm wrong, a lot of the machines in a ring topology will have two NIC cards, one for input, one for out. And then finally, the star topology, or not finally, NIC before we get to hybrid. Star topology basically is where a node connects to a central device, like we're going to use tonight, which is the hubs at the end of your table. These are actually called dummy hubs, okay? They're not smart devices. They're basically devices that first come, first serve. So when you connect to them tonight, it's you'll unplug the existing Cat5 in your computer you're sitting at, replace it with the Cat5 I gave you, plug it in one of these ports, and then the first come, first serve is the logic behind it. Unlike a A switch or a router, a switch, we'll talk about a switch, are smart in the fact that they can load balance, we can give certain IP addresses more data than other IP addresses. We can block IP addresses. You can't do that with a hub. It's just there for data flow. But it works. And you can still buy hubs too, by the way. They're nice. And you guys already have these at home. You might not have known this on your Wi-Fi router. If you have a Wi-Fi router at home, you have 4 or 5 ports generally in the back of your Wi-Fi router. If you have Comcast or Xfinity as your Wi-Fi provider or internet provider, the box they give you, I think, has 4 or 5 ports. I can't remember, something like that. Does anybody have Comcast, Xfinity for internet, for Wi-Fi? Do you use their box? Yeah, and it has, was it 4 ports? Yeah. And those are great if you're having, say, like we have the house, a Roku box. We have direct wired into that. Apple TV direct wired into that, and then the Wii network, the Wii gaming console direct wired into it, because I wouldn't recommend any of those devices being on wireless just because of degradation of speed. Now, the Wii the way we use it, works fine on the Wi-Fi because we don't really do any intensive gaming. A lot of the gaming we do is loaded on the I think the Wii Sports is the one we use the most, so, and it's all loaded on the DVD or something. And so anyway, but again, if you're going to do like over the air or over the internet, first-person shooter or any type of communication with video over the internet, direct wire is going to be better. Make sense? So star topology uses a node that connects it to a central device. Physical medium can be twisted pair of fiber. Single cable connects 2 devices. You might be thinking, could you use coaxial in a star? Oh yeah, definitely you could. You could definitely do that. There are converters for coaxial to work with switches and hubs. So yeah, you can. That's a little box. I think last week we looked at a box that converted, I believe it was fiber to Ethernet, right? Same type of deal. It would convert coaxial to Ethernet. You can get those. So it requires more cabling in a star because unlike a bus, you have one line going across and a ring, one line going across. In a star, you have one wire per unit going to the intermediate device, which would be a hub or a switch. So it's going to be more wires, more lengths of wires, but the advantage is fault tolerance in that you can centrally manage these much easier from a network interface device, a network LAN software that can see all your connections and see the health of it. In fact, at the end of the semester, we take a tour of the IT lab, and one of the first places we look at is and as you leave tonight, I think the light's still on when you guys leave. If you look, when you directly leave this room, take a left and look straight ahead, you'll see a room that's kind of lit up a little bit at the very end. That's the kind of the brain center of IT, and they have like big screen, flat screen TVs in there. And on those flat screen TVs have monitoring software that helps monitor servers and things of that nature. And the star topology helps in that because as a campus, we're pretty much all on star topology. And so it's very scalable though too. And so if I want to add 5 new computers in here, I just get 5 new computers, 5 lengths of straight cable, connected to the switches, done. That's all I got to do. And so they're pretty well segmented, easy to add on, unlike the other ones. So here's what it looks like as far as the layout for a star. It gives an example here of a switch, router, or hub. We're using a hub tonight. That device on top of the gray box here is a switch. Behind that, the little blue box I've shown you earlier this semester is the router. And so any one of those 3 can connect to the computers. And the most popular is basically this is the most popular the star is. And it has 1,024 addressable logical network nodes per network node. 1,024 per network node can be connected. So very scalable for small, medium, large size organizations. So logical topologies, basically what this does is the reason we use them in networking And we had you brainstorm, I think, in week 2. And the reason I do that is that's really where networking starts, is in the brainstorming of your topologies, how you're going to lay your stuff out. And you guys all had different layouts, remember, different designs for your computers, where you want them to be, where you wanted your switches to be. Same deal. So it's basically to help you understand where hardware is going to go. It will help you in costs later, because you can determine length of cable that way. You can determine types of cable you want, whether it be fiber, Ethernet, depending upon where you're placing your stuff. Maybe if it's near a shop area with a lot of engines and things like that, might need a higher end, higher noise resistant like fiber and not wireless. And then bus topology used by networks, basically with physical bus topology, has a star wired, can be called what's called a star wired bus topology, which is real popular. And also bus topologies all use Ethernet for the most part. The ring topologies, circular path. There's what's called a pure ring, which is just a circular, clockwise network. And then there's a star wired ring, meaning it's a mixture between the two. And they have lastly what's called a token ring. A token ring basically could be a mixture between the star and the wired or star and ring topology together. So pure ring, star topologies rarely exist because they're too restrictive, and they kind of, there's zero growth. But they do exist. An example would be supercomputers that have multiple computers daisy-chained together to connect their hardware, both memory and hard drive space. There's a couple in the U.S. and abroad that do supercomputing for, like, say, how to cure cancer, how to growth rate within the world, computations of DNA and different types of cells need supercomputers. And so it would exist in those type of isolated cases where it's not, you don't need growth, but you need speed. You need to make sure data is there. And so a lot of times the pure bus ring star can together do exist in those type of settings. And then lastly, the hybrid topology is more likely what you walk into today when you get a job in networking, because if it's been around any time, say like Ingersoll, Sunstrand, Woodward Governor, these guys have been around for a long time, pretty much, right? Since not too far after Rockford started. And so you're going to see all types of networks there, and that would be a hybrid of a mixture of all different types of networks combined in that. And you have several different options, from complex to simple setup, depending on, like, say, an R&D area would be more complex, and let's say a public area for people to log in to apply for a job, like in Walmart, or even, I think even Ingersoll has it as a front end, and Woodward Governor does. So the star ring is basically a star ring topology is a star physical topology and a ring physical and a logical topology. The benefit, you have the star fault tolerance of being able to troubleshoot things, and it's used in what's called an IEEE 802.5 token ring. And token ring basically just allows you to isolate your data better and to have better fault tolerance with data that makes sure data gets there as it's sent in a efficient time, not maybe the quickest time, but efficient time. So here's what it looks like on a star ring. You'll notice there's 2 lines going to each computer and to the intermediary device. So you do have redundancy on purpose. You do have speed, but not as fast as a pure star because it's got redundancy. But it works, and it works for situations where data has to get there regardless how long it takes. Really, just it's real important that data gets there. And so Workstations in a star wired bus topology are literally grouped in a, if you were to visually look at it from the top, like a star, basically. You've got the computers on the outside and the intermediary devices in the middle of that structure. Advantages, it can cover longer distances, easily interconnect with other networks and isolate different segments. Drawback is a cabling, double up the cabling, and it's a basis for most modern Ethernet networks today, is the star wired bus, which is this right here, like we have in this room, like we have in this building or buildings here at Rock Valley. So we all have this type of technology, and yes, working.
As far as security with these, is there an advantage to isolating something quickly if like a virus were to
No,
get into?
no advantage on viruses on any of these. They're about all the same. Well, I take it back. On the pure bus, it would be harder because you would have to go to each area to figure out where it's at. The benefit, though, of that would be it's going to be isolated to just that area, if that makes sense. Whereas on a star, it's much faster in spreading viruses because everything is interconnected so easily.
So the firewalls are more stringent on.
Firewall's the same. It's just figuring out where they're at, if that makes sense, is easier on a star than it is on a bus. But the security is literally better on a bus and a ring than on a star, just because things are isolated like they are on purpose. Because when they first started designing networks, when I say they, Al Gore started when the networks were first being designed, it was universities, right, that designed networks. And so you've been in school long enough to know everything at university level, college level, they want to follow rules and guidelines and be everything isolated for that unique area. So that's where it all started from, and that's where bus worked well, and so did ring. But as the needs were greater for us to be connected, interconnected, that's where the star topology actually sprouted from. We need to be able to connect each other quicker, faster, cheaper, and so that's where the birth of the star actually came out. And so you'll notice here, you got two hubs here, and you'll notice they're daisy chained together, the two hubs are. And even on these hubs we're using tonight, these old hubs, have 4 ports, but both of these, I believe, also have a port 1, and then they have I'll read it. It's this one here. Okay, this one here is on port 4. Port 4 and port 1. Port 4 can be used to daisy chain to another port. On this one actually has it on here. This one has a port 1, 2, 3, 4, 5, and then an uplink port. The uplink port on this would actually be used to daisy chain to this device, to this hub, to be able to daisy chain the hubs together. And so by daisy chaining them together with a Cat5 cable, or we'll say fiber like we do here on campus, in our IT room, we have all of our switches are daisy chained together with fiber. The length isn't that long, number one, between the two, generally. But they generally have to travel between areas that are kind of noisy maybe, or can be susceptible to noise. And so they spend a little bit more money on that. And like here, between building to building, it's all fiber on the underground tunnels. But on one side at the top, you've got your one star, and then the wired part is the part in between the two hubs, or routers or switches, and then the other star. That's why it's called star wired bus. Okay, the wired is what connects the different switches one to the other. Like in this building, in between each classroom, whatever the main switch is in this room, on this box here, is like the bottom one, I believe, has a wire running from that box to the next lab over here in the corner of the building. That lab has a wire running to the next lab in the next room, so on and so forth, all the way around the building. So there's one wire in between each room to connect the network. And it originates in the IT room. And you can literally, in this room, we have isolated on the switches and labeled each computer, right? In the IT room, they have isolated each room's main switch that's connected to that room. Does that make sense? So in here, it's computer by computer on the switch. In the IT room, it's main switch, main switch, main switch, main switch, main switch that they can turn on or off, basically. So let's say, for instance, here's an example. Years ago when I started teaching in this classroom, and we also used to teach, 213 is actually where I used to teach this class. We had everything set up on against a wall and like a horseshoe, which I kind of liked. But anyway, when we would do, like say, if I try to do an ethical hacking lab is what I like to call it. It's basically where we are in essence doing some penetration testing on the network for educational purposes, showing students things that you need to test for on the network, things that maybe vulnerabilities you can test for. Well, when I would do labs like that, it would really, we were on the same network here at the Rock Valley, so the people in the monitoring room would see what's going on, and I'd hear a student go, "Hey, I don't have any internet." And then about a minute later, I'd see a lab person come down and go, "Professor Conco, is everything okay here?" I said, "Yeah, I forgot to tell you we're doing lab." "Oh, okay, I'll turn the switch back on." They literally would just turn off our access to all network and internet access. They didn't know what was going on. And so, they learned my schedule each semester and would just ignore that activity, that it was an educational purpose. But every once in a while when I got a new person, they didn't know my schedule and they come down. So anyway, with that type of this type of network, you can easily isolate your traffic and troubleshoot traffic. So let's talk about backbone. Here in a few weeks, I believe it might be next week. I don't think it's this week. I think it's next week. I give you a take home. I give a couple weeks to play with it. We have to call local businesses to ask them a number of questions about their network. And one of the questions on that list is, what's your backbone? And backbone refers to the medium that network falls upon. Is it Ethernet? Is it fiber? Is it wireless? Is it WAN? Remember we talked about the WAN topology, which includes the internet connecting geographical regions one to the other. And so cabling, by connecting hubs, switches, and routers, you get more throughput, used for large organizations. And one of the backbones is fiber, much more expensive, but can go longer distances. Cat5 is usually used for hubs and switches. That would be another backbone in a large organization. Enterprise could be the WAN topology, like we talked about the first couple weeks in class, where you have a local LAN connecting to, say, the Stenstrom Center via a WAN link, either a direct link from the phone company, the ISP, which we have here. We have a direct T3 line between us and them. And then enterprise, the entire organization, significant building block, has multiple different types of complex backbones. Everything from fiber to Cat5 to wireless to WAN type of backbone. Does that make sense? And so organizations like ours and most larger businesses will have a complex backbone. Now, you'll hear terms like, what's your main backbone, right? Your main backbone. Well, for us, campus-wide, it would definitely be Ethernet is our main backbone between building, inside each building. But when you start looking at things visually from, say, a 30,000 viewpoint of all of our networks, what actually connects all of our networks together, our larger network, the small networks to a larger network, would actually be the WAN link, which would be the ISP provided direct line generally between location and location. So you've got I guess you have your localized backbone, and then you can have your geographical backbone as well, if that makes sense. So the simplest backbone is what's called a serial backbone. It's two or more interconnecting devices connecting using single daisy chain cable. All right, so an example would be like we're doing in here tonight. We've got two or more interconnecting devices, right? 3 on this side of the room, 4 on this side of the room. We're connecting each side of the room to a hub, and we can also connect each side of the room to each other with the uplink port between the 2 hubs, so for everybody can talk. Now in the lab you're going to do tonight, you're not going to do that link here, but we could do that to where you could all see each other and talk to each other and share files and all the good stuff. The benefit of this is it's very logical in its growth, and it's modular in addition. You can build things modular, so when you have new building, easy to add, new class, easy to add, new office, easy to add, no big deal. Bring a switch in, some Cat5 cable, done, right? Easy as that. Run a wire from here. Now in this room and in this building, the way these buildings are built, all the wires are ran through the floor. There's a 3-foot clearance between the floor here and the ceiling on the bottom floor, the basement. Most office buildings have it the opposite. They have the fake drop ceiling like we have here, and that's less secure because when you're running wires to a fake drop ceiling, it's easier for folks to get access to, hackers to get access to. The floor, a little bit harder because like in this room, the holes to drop to the floor are very small to get the wire into. And the only way to get to crawl into the crawl space of the floor is in certain areas in the building. Like in the IT, they have these little suction devices that suction panels. You pull up, and they have like 3x3 panels, which even myself, as big as I am, I can get through. To get into that panel, and then crawl on your hands and knees to fix a patch cable, run cable, whatever. And so it is high enough to where you can work in it, almost the height of these tables, almost in some areas. And so, because of that, the cabling in this room, between this room and the next room and this room in IT, is all ran through the floor. And so, if we did say, I don't know, say we had a room in the building that didn't have, for whatever reason, didn't have ports on the wall. Let's just say that, we could bring in a box like this or just a switch, run it through the floor, all the way to the IT server room, plug it in a switch to be able to connect to a network. Make sense? We could do it that way if we want to. Now, it wouldn't be the best solution, but it'd be a way to get somebody connected if we needed to. So the benefit, again, logical growth, low cost, just adding additional hubs or switches as needed when you need more growth within your organization. So here we have an example of what a network generally looks like. So you've got on the left side a router. Out here, outside of the router, is the internet. Okay? So as people come into your internet or people go out of your internet, that router is the first line of defense that has all the rules set for your organization. Routing, if you have a web server like we do here on campus, where your web server is located at when people type in rockefeller.edu, it's converted to an IP address, and then that IP address is then locally converted to a server somewhere here in the building for our website that's hosted. Second one you'll notice is a switch. And that's actually 2 switches, switch 1 and switch 2. That one can actually be connected to multiple other switches as well. And we could say this is an example of this building. We have in this room a router in this room that's literally connected. You can trace a wire from that router into the IT room. From that router, it's connected to the switches. Actually, in the back of the room, we moved them back there to connect to all the computers in here. In fact, there's 4 switches in the back of the room that the router's connected to. And then from this room, there is a wire that runs from one of the switches to the corner office over here that has about 8 or 10 computers, and it does the very same thing over and over and over and over again. So this room's unique in the fact that it has a router in it. Most rooms don't. Most rooms just have switches and then connect to computers. The reason we have a router is we're totally off the grid here in this room and also in the Cisco room. We control our own network traffic, basically. They've taken us off the general network grid here on campus so we can do our lab stuff for my classes, for Cisco classes. But most of your classrooms do not have the router. They're just going to have the switch coming into the classroom. But the building will have a router. Our building does. So in the IT office, in the IT lab, there is a router or multiple routers actually to do certain things and go certain places depending on what the traffic coming in is. From a router, you can also block or allow FTP. You can block or allow certain IP address or IP ranges. You can block also time ranges of when folks can access certain resources on your network. So it's the first line of defense, the router is. Now that doesn't mean you don't need antivirus software. It doesn't mean you don't need to watch where people go on the internet. They don't, all those things, common sense stuff you still have to do. But it does set up certain rules to help with the health of your network and the management of your network. Does that make sense? And so it's a simple configuration tool that you connect to via a console cable and a serial cable to that router. You can browse into it just like a web browser a lot of times and put your commands on a little black screen, save those commands, and then what I generally do is, and we do it here at the campus as well, there's backups of all configuration files for the routers, for the switches. We save them in locations. That way if a router poops out, which they do, switches poop out, which they do, it can literally wipe out all the configurations. Well, if you have a backup of that file, you can just literally reload it and you're back in business. Or worst case scenario, if a switch goes out and it dies, buy a new switch, upload the new router, new switch configurations, and you're back in business. And by the way, we do have in Cisco, we do teach router configuration, switch configuration, which I definitely recommend while you're here on campus, at least taking the router switch course to where switch configuration course where basically you learn those. There's not too many commands to learn, but the book that we use is, looks like a little Bible, but you always have to keep it with you. I have to keep mine because you can't remember all of them, and so, but the technology behind the rules behind routers and switches have pretty much stayed static in the last 4 or 5 years. Next, we've got a serial backbone, continuing on with the repeating devices. So repeating devices would be, in this building, would be the switches throughout the building that repeats that traffic along the way. If you're talking the Wi-Fi, you can also have repeaters in the Wi-Fi world as well. You can buy literally called repeaters or bridges, generally called repeaters or extenders, I think is what they call them. Like Linksys has extenders, if I'm not mistaken, is what they call theirs. You just plug it in, extend your Wi-Fi range. But in the wired world, there's some standards for serial backbone and defining the number of hubs allowed within a network segment. And then when you exceed those standards, you can have drop packets, drop data, data transmission errors. And here's a couple examples of how that can happen. You run your cable too long, right? In between your switches or hub hops. That'd be one example. Or you overload one segment instead of maybe separating with different switches. an example would be, I worked as a graphic designer for years, and so as a graphic designer, we had a lot of data pushing through the network, right? A lot of data. Video, audio, images. Video is huge in data. So if we added some new employees, a lot of times if it's 3 or 4 new employees, we'd get a whole other switch to connect those employees to offset the load that they were going to hit that network, and a lot of times separate the what's called into a virtual LAN to where they could literally have more bandwidth, more throughput to do their work. But when you don't follow the standards, like say if we just add them onto the existing switch, and say run a cable 300 feet or something like that to that computer, we'd see some major degradation in that new computer that's set up for that person or persons. So a distributed backbone talks about connecting a hierarchy of different types of connectivity devices, from LANs, WANs, MANs. Benefit of this, it's simple expansion, and it can be more complicated when you're connecting different types of LANs and LAN segments. And in this case, you would use routers to do that. Like in here, we have a router, but like I said, most classrooms don't. But we have a router because we are disconnected from our quote-unquote network here on campus. So here's an example of distributed backbone. You'll notice, and we could say this is this floor here in the building. Each one of these switches, we could say, is different parts of the floor here on the campus, on this building here. So we could say this is room 210. I'm just throwing some stuff together here. Maybe this one here is one right next to it, 211. Maybe this one right here is one of the offices. This is an office. Maybe this right here is 213. Maybe this right here is 268. This right here is maybe an IT room. And this right here is maybe 271. Just an example. And you'll notice how some of them have switches, some of them have hubs. The ones that have hubs generally are areas that aren't real intense on computer usage. Like they log in the internet, they go on Eagle. That's about it. Don't really need any smart device in there. Devices that do a lot of work on the internet and pushing data through the network would definitely need a switch. And for the most part today, when you go to buy and build a network, you're building most of the network with switches. Majority of the networks with switches. Not to say you couldn't use hubs, but majority of networks today are going to be built with switches. Here's another look at a different type of distributed backbone. You'll notice on the top end, it looks a little bit more organized just visually, but you've got your routers, first line defense coming in, and this could actually be separated into, let's say, buildings. So we could say this here is building 1, this here building 2, this here is building 3. Each one of them connected one to the other with a router. And we'll say that this wire here that I'm circling is fiber, and then these wires here are Cat5. Make sense? So that's a distributed backbone on multiple LANs. Benefits, easy to daisy chain. Consider length can be an issue, so consider that when you're daisy chaining them. Drawback, it is a potential for single failure point, because if one room switch dies, all the computers die, and that happens. But it is a drawback, but it's also a benefit in the fact that it's easy to troubleshoot. It's easy to troubleshoot those because it's all connected to one switch in that room. A collapsed backbone is basically using a router or switch where a single central connection point for multiple subnetworks is applied here. In this type of example on collapsible, the central router is a failure point, the single point of failure, because you only have one router that connects everything, basically, in that building. And so if that router is loaded with data, it can be very slow in transmission because it's a single point of not only failure, but it's a single point of entry and exit in that building as well. And you might have seen this happen, maybe an example at home, let's say, and I've used this before, but you're connected by yourself, then other guests get connected, or your kids or friends or family get connected, and you're like, man, oh man, this internet is dirt slow. I can't get to anything, right? And we've all had that happen, and that's because we're overloading that network with the with data. Advantages of collapsible backbone is it can interconnect to other subnetworks and can be centrally managed. Okay, I'm going to end on this one on a visual of a collapsible backbone. And all you'll notice on this one, we'll say the dotted lines again are fiber and the other are cat. You'll notice though at one central point of failure here, which is a router coming into the network, and then it's subdivided here. They're using hubs, but we could say they're switches. And so if this router fails, the whole network's down. Okay? And so a lot of businesses will actually have, because of that, multiple routers or fail-safe routers, where instead of having only one router, they might actually have 4 routers, one per segment. That way, if one router fails, only one segment fails. You can do that as well. And so again, it just depends on how much you want to spend. Cost-wise, really isn't that much more on a router, but how much you want to spend time configuring all 4, really. Okay, so let's go ahead. I'm going to save this.